Hello, good afternoon. I'm discussing about Lewis dot symbol, a way of representing atoms or molecules by showing the electrons as a dots surrounding the element symbol as the Lewis dot symbol. One bond is represented by the two electrons in the Lewis dot symbol. For the calculation of the total number of the covalent bond, we can use this formula S equal to N minus B over 2. S number of covalent bond, N number of electrons required to complete octet or duplet, V number of valence electrons, hydrogen is duplet, and order every elements or except hydrogen, all our elements are octets. Duplet means 2, octet means 8. See, this is the Lewis dot symbol of hydrogen peroxide. Okay. To draw Lewis dot symbol of hydrogen peroxide, first of all, we calculate the number of covalent bonds. In case of hydrogen peroxide, S equal to, S equal to N minus V. Okay, S equal to N minus V over 2. In the formula of hydrogen peroxide, that is the 2 hydrogen, that's why 2 into 2 multiplied by 2, because hydrogen is the duplet. Duplet means 2 plus only 2 oxygen here. So 2 multiplied by 8 because oxygen is the octet. This is the formula minus of the formula, and this is the 2 of the formula of the hydrogen, 2 hydrogen here. So 2 multiply 1 because the valence electrons of the hydrogen is 1 plus 2 oxygen here. So this is the 2 multiplied by 6 because the valence electrons of oxygen is the 6. In the calculation, we get 3. So we have to this number of covalents determines we have to complete 2 hydrogens duplet and 2 oxygen octet. We can make the covalence bonds 3. So how can we draw? See, this the hydrogen. We have denoted the electrons of hydrogen is dot, and electrons of oxygen is the cross. So this is the hydrogen. This is the electrons of hydrogen. This hydrogen 1 electrons from the oxygen and completes this duplet of the hydrogen. Similar in this case. And in case of oxygen, the hydrogen have shared 1 electrons. So hydrogen have the 6 electrons and 7 electrons with the electrons of this hydrogen, and 1 electron shares from the another this 1 hydrogens and becomes the 8 electrons. You can see 1, 2, 3, 4, 5, 6, 7, 8. In this case, this oxygen is the octet. Same in this oxygen. That's why the Lewis dot symbol of the hydrogen peroxide is in this way. This is the bond, this is the bond pair, and this is the lone pair. In case of nitric acid, see, S equal to N minus V. Sorry, not. In case of the nitric acid, S equal to N minus V over 2. In the nitric acid, only 1 hydrogen. That's why 1 multiply 2 because hydrogen is the duplet plus. There is the 1 nitrogen, so 1 multiplied by 8 plus and 3 oxygen, and so oxygen. That's why the 3 multiply 8 because nitrogen and oxygen octet. This is the formula of minus of the formula from the formula, And in the nitric acid, only one hydrogen multiplied with one, because the valence electrons of hydrogen is only one, plus only one nitrogen. That's why one multiplied by 5, because the valence electron of the nitrogen is the 5, plus 3 from the formula, 3 multiply 6, because the valence electrons of the oxygen is the 6. That's why the total number of covalent bonds is the 5. See, we can complete octet in duplet, octet of the 3 oxygen and 1 nitrogen and 1 hydrogen. The duplet form the 5 covalent bonds. So I have started from this hydrogen. The electrons of hydrogen is denoted by dot, and electrons of oxygen is denoted by the cross. So this hydrogen have taken 1 electron to complete duplet of this hydrogen. Uh, but in case of this oxygen have the 6 lone pair of, 6 valence electrons, and this oxygen have taken 1 electron from this hydrogen and 1 electron from this nitrogen. So this is the octet, this oxygen. But in this case, this oxygen have the completed this octet by taking the 2 electrons of this nitrogen. And also, this oxygen have also taken 2 electrons from the nitrogen to complete the octet of this oxygen. But in case of this nitrogen, the nitrogen have this 5 electrons, and 1 electron taken from this oxygen, and completes how many electrons? It is 5 and 6. But 2 electrons are taken from this oxygen. This nitrogen have the 8 electrons. See, this hydrogen and oxygen have sharing the 1 electron equal. That's the covalent bond. And similarly, this oxygen and this nitrogen have also shared 1 electrons, and that's why this covalent bond. This has the 2 lone pairs. Okay, so this lone pairs, and between this oxygen and the nitrogen have the sharing 1 electrons from this oxygen and 1 electrons from nitrogen. That's why this covalent bond. And see, between this nitrogen and this oxygen, the oxygen have the 6 electrons, and 2 electrons have taken from this nitrogen, but this nitrogen have not taken from this oxygen. That's why there is the coordinate covalent bond, and oxygen have the 6 lone pair of the electrons. But in case of this oxygen, the oxygen have 2 electrons taken from this nitrogen, but and also this nitrogen have also taken to complete the octet 2 electrons equal to electrons. That's why 2 covalent bond, that is the double bond, and that is the lone pair of electrons. This is the Lewis dot symbol of nitric acid. In case of ammonium ion, this is the number of covalent bond, and minus V over 2. That is the only 1 nitrogen. That's why 1 multiply 8 plus the 4 hydrogen, 4 multiply 2. This is the minus from this formula, and 1 is only 1 nitrogen, and multiply by 5, because the valence electrons of nitrogen is the 5, plus 4. These are the only 4 electrons, and multiply by 1. And you remember that if the in that is the positive charge, or the cation, you should to deduct or uh, subtraction the number, how many charge is there. See, in the ammonium ion only 1 plus charge. That's why I have deducted or subtracted 1. See, divide over 2. That's why the 4 in this from this number of covalent bonds, we have to make 4 covalent bond, and we have to complete the octet of the nitrogen and the duplet of the 4 hydrogen. See, Uh, and also, we have remember another important point. If the positive charge in that ion, or you are writing the Lewis dot symbol of the cation, you should subtract, or should reduce the electrons of the sideways, not central atom. See, in that is the in central atom is the nitrogen, and surrounding atoms is the hydrogen. So I have subtracted or reduced this hydrogen electron, because this is the plus. You should remember 2 points. One is the you subtract in the valence electrons, and another one is the in the writing the lavish dot symbol, you should subtract or reduce the electrons of the surroundings, not central. See, so I have reduced this hydrogen one electron, that's why it is plus. So this hydrogen H plus, that is no electrons. So this hydrogen have taken to complete octet 2 electrons from this nitrogen. But in case of other 3 hydrogens have the one electrons, this hydrogen, every 3 hydrogens have taken 1 electrons from nitrogen. That's why these 3 hydrogens have the covalent bond, but this hydrogen have the coordinate covalent bond. Lewis dot symbol of nitric acid. And we have the formula S equal to N minus Z over 2. This is the number of covalent bonds. That's why we should know in that molecule is there only covalent bonds. So consider, let nitric, potassium nitrate. Potassium nitrate is not covalent compounds. This is the ionic compounds. So that is the ionic bonds between the potassium and the nitrate ions. So we dissociate this, dissociate the ionic or electrovalent bonds. Then you have to only you calculate the number of covalent bonds. So in the nitrate ion, that is the covalent bonds. So we can calculate the number of covalent bonds of the nitrate. So we are calculating S equal to N minus B by 2, like other another molecules. So only one, this is the nitrogen, so the 1 multiply 8, because nitrogen is the what? Octet plus 3 oxygen, 3 multiply 8. This minus from the formula, and 1, and because only 1 nitrogen, and sorry, this the nitrogen have the okay. Okay. I am calculating the number of covalent bonds. So that is the in the nitrate ion only 1 nitrogen, and the valence electron is the 5, plus there is the 3 oxygen, so 3, and the valence electron of the oxygen is the 6, and plus 1. I have already told you, if the plus charge, you should subtract, and if there is the minus charge or anion, you should add. Minus negative means there is the electrons. So add. There is the only one negative charge. So I have added 1. So I have we remember that in case of the cation, you should subtract how many plus charge, and in case of the anion or negatively charged radicals, you should add how many number of negative charge. So this in calculation, that is the 4, is from the 4 number of covalent bonds, and we have to complete the octet of the 3 oxygen and 1 nitrogen. See, and nitrogen have the 5 valence electrons. And also I have already told in case of the ammonium, if there is the positive charge, you should reduce electrons of the surroundings, not central. Just opposite, in case of the negatively charged, you should add electrons in the central, not in the surroundings. In the central is the nitrogen. So nitrogen have the 5 electrons and 1 electron added. So that's why the 6 electrons. And oxygen, I am starting to complete update from this oxygen. Oxygen have the 6 lone pair of electrons and 2 electrons from this nitrogen. Every oxygen have the similar case, and oxygen have 2 electron takers from the nitrogen. But in case of the nitrogen to complete octet, nitrogen have the 6 electrons and 2 electrons taken from this oxygen. So so that's why this nitrogen and oxygen have 2 covalent bonds, that is the double bonds, and 2 lone pairs. And this oxygen have taken the 2 electrons from nitrogen, but this nitrogen have not taken. That's why this coordinate covalent bonds. This hydrogen have also similar case. And we have to in the bracket with this minus negative for nitrate and the potassium plus. In this way, we can write the Lewis dot symbol of potassium nitrate. Okay, Lewis dot symbols of the boron trifluoride. Boron is the exceptional case. I have already told you hydrogen accept hydrogen, all every atoms are the octet. But in case of the boron, and that is no or not octet, is the exceptional. We should have to write 6. Only one hydrogen, but and 1 into 1 multiply 6 plus 3 fluorine, 3 multiply 8, and this is the formula minus from the formula. And boron have the 3 lone pair, valence electrons. See, 2s2 2p. This is the outermost shell. 2 to 3 electrons, 1 into 3 plus 3 fluorine, 3 multiply 7. Fluorine have the 7 valence electrons. I'm trying to complete from the fluorine. Fluorine have the 7 valence electrons and 1 electron taken from the bromine in this way. And every fluorine have the similar case. And fluorine have the 7 electrons and 1 electron taken from the bromine. And bromine have also 1 electron taken from every 3 fluorines, and bromine have the 3 electrons and 3 electrons taken from the 3 fluorine. That's why 6 electron. This is the exceptional case. I have already discussed, already told you. Okay, thanks for watching, and I request you like, comment, share, and subscribe. Thank you for the patience. That is now. Bye bye. See you again.